Oceanography presentation by Constanza Bradwell on Iceland. What is the present location of Iceland? Iceland is located in the northwest of the United States, more precisely located between the Green Sea and the Atlantic Ocean. It is believed to have been formed by Iceland's hotspot splitting Pangaea apart. It is mostly composed of igneous rocks. More specifically, Iceland is located in the mid-Atlantic ridge, right over here. As shown in this diagram, Iceland was part of Pangaea. When Pangaea drifted apart, Iceland's hotspot formed. Iceland lies on the actively divergent boundary, which is seen right over here, on the actively divergent boundary composed of two large continental plates, the North American plate and the Eurasian plate. As the seafloor spreading took place by the drifting of the plates, Iceland is now located in the North Atlantic Ocean. What is Iceland's general mineral composition? Iceland's general mineral composition consists of 90% of basalt, which makes up Iceland. Iceland, being centered on the mid-Atlantic ridge, it's an active spreading rift that demonstrated as the plates drift, there is volcanic activity and magma is built, which then becomes basaltic volcanism. As lava erupts from a volcano, it comes out as liquid magma, which then hardens and its volume shrinks and becomes different shapes, the process of basaltic columns. Now, 300 MA years ago, Greenland, as part of Pangaea, made it possible for the formation of Iceland. The breakup of Greenland and Newfoundland subsequently formed the seafloor around Iceland. As the continents drifted apart, a new plate boundary formed. Now, the mid-Atlantic ridge. As the divergent plate boundary was created, this diagram demonstrates as crust is pulled apart, magma fills in the gap. Right over here. In a gradual process, an oceanic crust was produced beneath the North Atlantic. In this case, the zone of spreading apart is the mid-Atlantic ridge, consisting of the North American plate and Eurasian plate, constantly spreading apart, which is demonstrated in this diagram. Iceland's hotspot. Mid-ocean bridges do not usually build up high enough to rise above sea level. However, Iceland has lots of eruption. This is because of laying on an active boundary plate and a hotspot. Iceland's mantle plume has been active for years and even predates the North Atlantic. Iceland's mystery. The formation of Iceland itself, it's a mystery for geologists. Some believe that the separating of the tectonic plates opened a way for the mantle's plume to go upwards. Others believe that the rising plume caused the tectonic plates to separate. Late Cretaceous, 80 to 70 million years ago. Located above the mid-Atlantic ridge, there is geological evidence of Iceland's hotspot likely having moved below Greenland. As the North Atlantic Ocean spread apart, Greenland moved over the hotspot. By 75 million years ago, it was implied that Iceland's hotspot was much older to the rift of the Atlantic Ocean, and this demonstrated that the rift did not occur because of the stationary plume. Mid-Paleocene, 60 million years ago. As the hotspot located near Greenland and the mid-Atlantic Ocean, volcanism caused by the hotspot united the North American and Eurasian continents, forming a land bridge once they drifted apart. As this diagram demonstrates, once the continents drifted apart, this future no known as the Greenland-Scotland Transfer Ridge, created an undersea ridge. 57 to 53 million years ago. Around 57 to 53 million years ago, igneous rocks were found near both sides of the Mid-Atlantic Ridge, which originated around the time North American Plate and the Eurasian Plate separated and seafloor spreading took place. This evidence of igneous rock led geologists to believe that the formation of the hotspot beneath Iceland contributed to the drifting of Pangaea and subsequently formed the North Atlantic Ocean. Now, today, Iceland lies on the Mid-Atlantic Ridge. Its plate tectonics are constantly shifting as well as laying on a hotspot. Iceland has active volcanic activity. About every 5 to 10 years, eruptions take place and is home of about 35 volcanoes that have erupted in the span of 10,000 years. Iceland, to this day, because of the movement of the plates spreading apart, is accompanied by natural disasters of earthquakes, reactivation of volcanoes, and creation of new volcanoes. Now for the future. The future of Iceland does not look icy. Unfortunately, Iceland is said to be iceless by 2200. The two main reasons are global warming and gravity. Global warming is causing ice to melt faster than usual, and gravity tends to pull the heavy weight of an ice sheet towards the ocean. But as the ice sheet melts, water moves away and drastically affects the fissures and island itself. Thank you.